Here in this video we're going to take a look at the chain rule and how we use that to take derivatives. Remember, when we're using the chain rule, we have a composition of functions. So the notation that you'll see for the rule is h of x is equal to g of f of x, and h prime of x is equal to g prime of f of x times f prime of x. And this second set of notation you see is another way to do it if you took the pieces apart. So if you did it as two different functions. So if we do y is equal to g of u and u is equal to f of x, then dy dx is dy du times du dx. In this first example, we have 7x squared plus 4x all raised to the third. Chain rule works is f prime of x is equal to, we multiply the 3 down out front, so we have 3, and then we're going to rewrite the entire terms in the parentheses. And now we're going to subtract 1 from the exponent, just like we did for the power rule. And now we're going to take the derivative of inside the parentheses. So we have 14x plus 4. So that's the first example. For the second example, we actually here are going to need the chain rule, but we need to rewrite it in a way that we can see it. So again, we're going to rewrite the function first, and we're going to say that this is 4x squared plus x raised to the 1/3. And now we can see the use of the chain rule much better. So we have f prime of x is equal to, multiply down the exponent, 1/3, rewrite everything on the inside, subtract 1 from the exponent, so we get negative 2/3, and now times the derivative of inside the parentheses, which is 8x plus 1. And now I'm going to rewrite this without a negative exponent. So f prime of x is equal to 8x plus 1 divided by 3 times 4x squared plus x to the 2/3. In this next example, again, we're going to have to rewrite this. Now, you see this, and you definitely could use the quotient rule and then the chain rule combined. In this situation, I'm going to rewrite it so that I only need to use the chain rule. So I'm going to say that this is equal to 4 times 2x to the 5th plus 1 raised to the negative 4. And now we can take the derivative using the chain rule. So we have f prime of x is equal to negative 4 times 4 gives me negative 16. Rewrite the inside terms. Subtract 1 from the exponent, negative 5. And now times the derivative of the inside, which is 10x to the 4th. And I'll do one simplification step. So I have negative 16 and 10x to the 4th all in the numerator. So I have negative 160 x to the 4th divided by 2x to the 5th plus 1 all raised to the 5th power. Now here in this last example, this is where I want to illustrate the other notation that we had up there. So we want to find dy dx. So up there we talked about dy dx being equal to dy du times du dx. So here, dy du means take the derivative of the y equation with respect to u. So we have dy du is equal to 3u squared. And we also have du dx, which is the derivative of the u equation with respect to x. So we have du dx is equal to 2x. So now that we've done both pieces, we can say that dy dx is equal to 3u squared times 2x. And we can simplify this and say dy dx is equal to 6x times u squared. And now what we need to do is substitute u in for our formula so we have everything in terms of x. So dy dx is equal to 6x times x squared plus 1 squared. So that's how you'd break it up in pieces, and you can also put this function together and see that it works the same way. So if we combine this function, we would have y is equal to u cubed, and u is equal to x squared plus 1 cubed. So now dy dx is equal to 3. Rewrite the inside, x squared plus 1. Subtract 1 from the exponent, and then times the derivative of inside the parentheses, which is 2x. And you can see that we get the same answer that we got before. Sometimes in the directions they ask you to do it in pieces, and if they do, then you need to be able to do it that way. Otherwise, you can do it either way, whichever one you're more comfortable with. And that's the chain rule.